Okay, this is the P2 paper from October 2023. It's question number 9. This question involves some differentiation. We're going to be finding an increasing function, and also then we're going to do integration. We're going to find this region R here, which is obviously going to be the area under a curve. So let's have a look at the first part. 9 part A, it says for this function here, remembering that x is greater than or equal to 0, can we find the range of values for which y is increasing? So let's explain to the examiner what we're going to do. Y is equal to 2/3 x squared minus 9x to the half plus 13. And if a function is increasing, it means that dy by dx excuse me, is always greater than 0. So let's find dy by dx. dy by dx is just differentiating. So multiply by the power, take 1 off the power. That's going to give me, 4x over 3. Multiply by the power, take 1 off the power, is going to give me minus 9 over 2 x to the, but it'll be minus a half now. And differentiating 13 obviously just gives us 0. So for an increasing function, let's write this out, for an increasing function, dy by dx is always greater than 0. So let's do that for our function. We've got 4x over 3 minus 9 over 2 x to the minus a half. I want that to be greater than 0. So let's get rid of the 3 and the 2 by multiplying by 6. But let's also get rid of x to minus half by multiplying by x to the half as well. And we're allowed to do that because it says in the question that x is greater than or equal to 0. So we've got no issues with our inequalities when we're doing that. So if I multiply that all by 6x to the half, I'm going to get 8x to the 3 over 2, and I'm going to get minus 27 is greater than or greater than 0. Okay, so once we've done that, we can just rearrange this. I'm going to get x to the 3 over 2 is greater than 27 over 8. So x is going to be greater than, if I want to get rid of that 3 over 2, I need to do 27 over 8 to the power of 2/3. I'm not going to write that in there, but just to show you what we're doing, and that works out that x then is greater than 9 over 4. Okay, so first part done. Second part says, you can read through all that information, pause the video if you want, read through all that information, but what they're asking us to do is to find the region R there. Now, if I drop a line down from vertical line straight down there, the region R that I want is going to be the area under the curve from 0 to 9, that area, subtract the area of the triangle. Okay, so I'll do that in a second, but how do I work out the area of the triangle? Well, if I want to work out the area of the triangle, I'm going to need to know this point here, which I'm going to call A, because then it's just half base times height. Height I know is 9, but I'll need to know what the value for A is. How do I find the value for A? Well, we're sort of working backwards here. That means I need to know the equation of this line, which is the equation of the tangent that was in the information. So I need to be able to work out the equation of a tangent. If I work out the equation of a tangent, that point there will just be when y equals 0. How do I find the equation of the tangent then? Well, I've got the points. The only thing that I need to do then is to work out the gradient of AP, because if I've got the gradient of AP, then I can go through and do everything that I need to do. So that's explained to you guys what we've got to do. Now let's actually explain it to the examiner as well. So for part B, region R is equal to the area under the curve. I'm going to put that as being integral of y dx between 0 and 9 minus the area of the triangle What's the triangle? Let's call this B. The triangle ABP. That's the triangle ABP, which means I need to find A, which means I need to find the equation of AP, and in order to find the equation of AP, the first thing I need to do is to find the gradient of AP. So that's what I'm going to do now. Let's work out the gradient of AP first of all. So the gradient of AP doesn't tell me anything about the line there. So the gradient of AP I'm going to work out that at x equals 9. So I want the gradient of AP at x equals 9 is just going to be dy by dx at x equals 9. So the gradient of AP, dy by dx, remember, was 4x over 3 minus 9 over 2 x to the minus a half. And now we're going to put x equals 9 in. So I'm going to get 4 lots of 9 over 3 minus 9 over 2 lots of 9 to the minus half, and just work out what that works out to be on your calculator. That works out to be 21 over 2. So I've got the gradient of AP. If I've got the gradient of AP, it now means I can find the equation of AP. Building this up very, very slowly. So the equation of AP is equation of a straight line. Y minus y1 is m, x minus x1. What do I need for those things? I need x1, y1, and m. x1, y1 is the point. The point was 940. The gradient we've just found is 21 over 2. So if I put all of that information in now, so that's y minus 40 is 21 over 2 x minus 9. Let's tidy that up, multiply everything by 2. We're going to get 2y minus 80 equals 21 x minus 9 here. We're going to get 2y minus 80 equals 21x minus 189 here. We're going to get y works out to be equal to, just rearrange all that, 21 over 2x minus 109 over 2. And then what I want is I want to find points, point A, remember, and point A is going to be where this line, where y is equal to 0. So keep going here. For point A, y is going to be equal to 0. So if y is going to be equal to 0, I get that 0 is 21 over 2x minus 109 over 2. So that means x works out to be 109 over 21. So going back to my diagram here then, I now know that this point is 109 over 21 is that point there. So I can now work out the area of my triangle. So area of the triangle is half base times height. So that's going to be a half, well, the base is 9 minus 1 over 9 over 21 times by the height times by 40. That works out to be 1600 over 21. And now I've got to, again, tell the examiner what I'm doing here. So region R, in fact, before we even do region R, actually, let's do the integrals. We haven't done it yet. So the area under the curve is next. A lot of work on this one. Area under the curve was that integral between 9 and 0 of y dx, wasn't it? So that's the integral between 9 and 0 of 2/3 x squared minus 9x to the half plus 13 dx. Just be nice and patient with this. It takes a lot of time, but don't make any mistakes as we're going through. Integrating is add 1 onto the power, divide by the new power. So add 1 onto the power, divide by the new power. Same thing again, add 1 onto the power is going to give me x to the 3 over 2. Divide by the new power is either divide by 3 over 2, that's what I'm going to write down. You could do multiply by 2/3, that would be the same thing. And integrating 13 is just x. All between 9 and 0. And so I need to put 9 in. I'm going to get 2 lots of 9 cubed over 9 minus 9 lots of 9 to the 3 over 2 divided by 3 over 2 plus 13 lots of 9. Tied up the handwriting there. And then minus 0. Obviously the other one is minus 0 plus 0. Okay, so that all works out to be 162 minus 162 plus 117, or in other words, 117. And so finally, after all that work, so the area R is that 117 minus the area of that triangle, 21 there, which worked out to be 857 over 21 square units. So unit squared, whatever the units are there. Right, that's a huge question, isn't it? Lots and lots of different parts to that, but hopefully that all made sense as I went through it.